So today, what we're doing is it's one of those days that we have something brand new. It's not really brand new, but it's a brand new concept. It's a brand new word. Unless you've taken Math 3 before, the word logarithm, probably never heard of. I know before I took Math 3, I'd never heard of a logarithm. Okay. The reason a log is it's a brand new concept, but it's related to what we've been doing. Okay, so it's not completely new. Okay, so a logarithm. When do we use logarithms? Because there's log buttons on your calculator. If you have a regular calculator, or any scientific calculator has a log button. Even if you have a phone calculator, there's always a log button. You've probably seen it, just overlooked it because you never needed it. Okay, well, this chapter we're going to need it. So what is a logarithm? Well, the logarithm is just a special way to ask a specific question. Okay, so if I have this right here, what exponent is required to go from b, my base, to my answer? Which exponent is needed? When you come up with that answer, that's what it'll equal. Okay, so we use exponents, but we're asking a different question. We used to ask questions like 2 to the third power equals 8, where 8 was the answer, 3 was the exponent, 2 is the base, right? Now what we're doing is we're reversing those, kind of turning those around, putting the 2 and the 8 together, and the 3 is now the answer. Okay, so I color coded them so you can see. This is the way we're used to seeing them on the board here. If you can see on the board, this is the way we're used to seeing them. This is the way logs present them. It's still the same numbers, right? Just moved around. Okay, so when do we use logs? We use logs when we want to figure out an unknown exponent. Okay, anytime we want to find out an unknown exponent, if an exponent is unknown, that's when we use logs. When do they use logs in real life? Well, in California, we don't have to worry about hurricanes, tornadoes, but what is our big natural disaster that we have to worry about? Earthquakes, right? Earthquakes. California, we have a lot of earthquakes, right? Some really tiny, you don't even feel. Some, the ground shakes a little bit. But we do have earthquakes. We have a fault line. It's called the San Andreas Fault that runs right smack through California, all the way through California. Okay, so we have to worry about earthquakes, right? Well, the way they measure earthquakes. How do they measure earthquakes? Does anyone know how they measure earthquakes? Yeah, what is that called? Does anyone know what that's called? That system is called? Starts with an R. It's called a Richter scale. Yeah, it's called a Richter scale, right? So if someone has, sometimes you'll hear this place had a 5.8 earthquake. 5.8 is decent. It's not super bad, but it's a decent earthquake, right? If you're right by where that earthquake happened, that's, there might be some damage there. 8.0 earthquake, 8.1, 8.2, that's devastating, right? That could level buildings, right? So, how do they come up with those numbers? Well, just like Brian said, it's based off of exponents, right? Because the magnitude of earthquakes, right? Because underground we have plates, and when those plates kind of act up, they create earthquakes. That's what creates earthquakes, right? So, and then Richter scales is what we use to say how bad it was, right? So how do they come up with those numbers? Those numbers are just exponents. So next time you hear 5.0 earthquake, 5 was the exponent, right? It was 10 to the fifth power. That was the magnitude, right? As the exponents get bigger, the more magnitude, right? So that's one way they use them, okay, in real life. Um, so getting back to this, logarithms. Logarithms are when we want to solve for an unknown exponent. So we either write in log form or exponential form. I put exponential form first here because we're used to seeing that, right? So I put it on the board too. So we're used to seeing, I color coded it on the board, so I'll color code it here too. We're used to seeing a base, right? A base to an exponent power is equal to an answer, right? 2 to the third power equals 8. 4 to the negative 2 power. Remember, negative power means flip and then square, so that's why it's 1 over 16. Okay, we're used to seeing things like that. Now, with logs, how do we know it's in log form? Well, it's got the word log in it. That's the first thing. How do we know it's in log form? It's got the word log in it. So the base is still called the base, but it's going to be a smaller number, and it's going to be right next to the log. So the base is here. The answer goes right next to the base. And the exponent doesn't go next to the base this time, it goes on the other side. Okay? So if you want to convert one to the other, you change it from the base goes, if you want to go from exponent to log, the base goes down there. Whatever the number was here, it goes there. The exponent goes here, and the answer goes here. We're mainly going to go this way. Today, we're going to go this way. So the base goes from here to there. The answer goes from here to there, and the exponent goes from here to there. Okay? That's mainly what we're going to focus on today. Okay? Same numbers. I'm not changing the numbers around. You see on the board here, 2 is the base, 8 is the answer, 3 is the exponent. 4 is the base, 1 over 16 is the answer, negative 2 is the exponent. Same numbers. I didn't change them. They're just in different spots. Okay? Okay, so one way is by color coding them, right? The other way is something I didn't come up with it. A teacher who teaches this taught me this trick. It's called the loop trick. It's called the loop trick. How do I go from one to the other? How do I go from this one to this one over here? So this is the loop trick. You always start with the base, right? You always start with the base. So the base is right here. And then you make a loop to here, and then you finish with a loop here. Now look at the order I just went in. I started with B, and then I went to X, and then I finished with A, right? So that helps you with the order from over here. You can also do it the other way. You can start with the base over here and use the loop trick to go the other way. So start with the base, and then go to A goes here, and then go to X goes here. That works too. Okay, they both work. Because what we're going to be doing is going back and forth a lot. Change it to exponent, okay? Change it to a log, okay? Change it to an exponent. No, change it to a log. We're going to be going back and forth quite a bit in the next couple lessons. So the easier you can go back and forth, the easier this is going to be. Okay, whether you use just a color coding system or whether you use the loop trick, up to you. Okay? All right, so let's look at example number 1 now. Example number 1. So we got to convert. So tell me right now, when you're looking at number 1A, what part is missing? What part is missing? Blue, A, or green? Blue, red, or green? Base, answer, or exponent? Which part is missing here? Exponent, right? Yeah. We need the exponent. So 7 to what power gives me 49? 2 is the answer. That's the exponent, right? I was missing the exponent, right? One way to check is to use the loop. Start with 7. 7 to this power equal that. Yep. If it equals, then you know you did it right. Okay. So over here, 2 to what power gives me 32? No, not 16. What power? Not 6. So 2 times 2 is 4. 2 times 2 is 8. 16, fifth power. Fifth power. Because 2 to the fifth power equals 16. We're only talking about powers here, or 32, sorry. We're only talking about powers here. I'm not talking about regular multiplication. It's just powers. Because I'll see a lot of people, they'll say, oh, 2 times 16 makes 32. Yeah, but that's not a power. We want a power. Okay. All right, letter C. What exponent is needed? Start with 4. Your answer is 1 over 64. Which power did they raise it to? So in other words, what power? So what did they do? There's two things they did. What did they do to go from 4 to 1 over 64? What's the first thing they did? They flipped it, right? They flipped, right? From 4 to 1 over 64, it got flipped. So that means I'm going to need a negative power. Okay. So once it's flipped, 4 to what power makes 64? 3. Right? Because this means 1 over 4 to the third power, and then 4 times 4 times 4 makes 1 over 64. Okay? That's what negative powers do. Negative powers flip it, either to the bottom or to the top. Okay? Okay. So you're going to see the ones on your calculator, the ones on your phone calculator, only have a certain base. They don't have base of 4, base of 2, base of 7. They only have one base, and those are called common logs. Common logs are when no base is showing, that's base of 10. So if there's no base showing on the log, it's always going to be 10. Those are called common logs. Our counting system is called a base 10 counting system because we count to 10 and then we start with another group, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we start with another group, which is 11, 12, 13, 14, 15. We start every 10, right? We have a base 10 system. Okay. Some counting systems have base 2, which is 1, 2. Then you start with another set. We don't have that. We have a base 10. So that's why it's called a common log. So like A, letter A, 2A. There is no log base written. It's not written here. But it actually is written. It's 10. Okay? So now 10 to what power gives me 100? 2. Use the loop trick to prove it. Because 10 squared equals 100. That's true. Okay. This guy down here, it's got a base of 10. So what power does 10 need to be 1 over 100? It's got to be a negative. Good. And then negative 2. Good. Because you flip it and then you square it. Okay, so 2 to the negative 2 power, 10 to the negative 2 power equals 1 over 100, right? We flip it and then square it. Okay. Letter C. 10 to what power makes 1 as an answer? 0. Yeah, 0. Because 10 to the 0 power equals 1. Okay. So let me try this one. Let me give you this one real quick. How about this? Log of 0. It's base of 10, right? No base written, so it's base 10. What power would that be? So what I'm asking is 10 to what power gives me 0 as an answer? Can't be 0 because we just said 0 makes this power right here. Because if 0 is the answer, that means we did something wrong here. We didn't do anything wrong. That's correct. So would that be there? Not 1, because 1 would be just 10, right? 10 to the first power equals 10. Negative 1 would just flip it to make it like that. It's kind of imaginary. It's not even imaginary. It's called undefined, or there is no answer. There is no answer. So we say undefined. There is no number that would give me that. I can't get 0 with a power. I have to multiply just times 0, right? I can't get a number. I can't get a power. Powers don't work that way. Okay. All right. So now let's move up to number 3. Example number 3. So these are the same types of problems. They just have x's instead. They're the same type of problem as these over here. They just don't have blanks. They have unknowns, right? So over here, I'm just asking the question. I'm saying 7 to what power makes 243? Or 343, sorry. 7 to what power makes 343? 7 to the first, 7 to the second, 7 to the third, 7 to the fourth, 7 to the fifth. Which one is it going to be? 3. 7 times 7 times 7 makes 343. Okay. The next one, x to the second power equals 36. Mm-hmm. What times itself makes 36? 6. So the base is 6. Okay. The last one, 7 to the third power equals what? So now we're looking for the answer there. 343, yeah. Right? So A, we were looking for the exponent. B, we were looking for the base. C, we were looking for the answer. We're just missing one, right? Okay. The last part, example 4 is exactly the same. But the difference is we have fractions and negatives. Which part is this? Which component of our, it's the exponent part, right? What happens if we have negative exponents? We talked about that already. What happens if we have negative exponents? What do we do? What do we do if we have a negative exponent? It flips, right? Either to the top or to the bottom, right? What happens if we have a fraction exponent? Not switch. You guys had a quiz on this. This was our last quiz we had. You had a lot of problems like this. What happens if we have a fraction exponent? Well, the negative means positive. I'm not talking about the negative. I'm talking about the fraction. What if we have a fraction? What if we have a positive fraction, negative fraction? No. You guys took a quiz on it and you guys did really well on it. Do we need to take another quiz right now to see? No. Okay. So tell me what you guys did, because you guys showed me then. And this was like a week and a half ago. It wasn't even like that long ago. So what did the fraction exponent mean? Because when I change this, it's going to look like this, right? It's going to be like this. It's going to say 36 to the negative 1/2. That's what they want me to find. So we flip it to the bottom. Okay, well, what does 1/2 mean then? How do I solve it with a 1/2? What does the top number mean? The top number is the power. The bottom number is the root. That's what it means. Okay, so we're going to use that today as well. So the top number is 1. 36 to the first power. The root is 2. Well, if I'm looking for a root of 2, what is that another way of saying? What's another way of saying a root of 2? Pairs or square root. Square root. So I have 36, 136 in there, and I'm looking for a square root. So square root means pairs. So how many pairs do I have? How many pairs do I have? 1 pair of 6s. Done. Believe it or not, this is the hardest part of this. And again, you took a quiz on it and you guys did really well on it. So you know it. It might be somewhere in the back of your brain, but you got to bring it back to the forward. And if you don't, you have notes on it. We took notes on this weeks ago. Okay? 2-3 weeks ago. So you have them in there. Okay? That's how I found this part here. That's just from your notes. Okay? So let's do the second one. B. So the first thing is change it to an exponent. Okay, so I have 729 to the negative 5/6 power equals x. I'm not going to put x yet. I'm just going to try to simplify that first. Okay, so what do I do now? What's the first thing I got to do? How do I simplify this? Before I do that, what do I do? There you go. To make the power positive, okay, the top is the power, the bottom is the root. Okay. So I'm looking for groups of 6. Groups of 6. I only have 5 729s. Why did I put 56? It's supposed to be 729. Don't know why I changed that. I only have 5 of them. So what do I do? What did we do when we took the quiz? We break down 729, right? Because 729 might have groups of 6 in there. So I break down 729. 729 is 243 times 3, or 81 times 9. I think this is 81 times 3. And then 81 is 9 times 9. And then each of these guys has a 3. Okay. So each one of these 729s is going to have 1, 2, 3, 4, 5, 6 threes. Each one of these guys is going to have 6 threes. So how many threes do I have total? So I have 1, 2, 3, 4, 5, 6. Each one of these 729s has 6 threes. So how many threes do I have total? More than that. Think about it for a second. Let me say it one more time and then I'll let you think about it. So 729s. How many 729s do I have? 5. Each one of those 729s has 1, 2, 3, 4, 5, 6 threes. 30. There you go. So another way of writing this is instead of 729, I can say I have 3 to the 30th power. All right? Because I have 6 threes. 729 has 6 threes. And I have 5 of those guys. So that's why I have 30. Okay? So now I'm looking for groups of 6. How many groups of 6 do I have? 5. So I have 3 to the 5th power. 3 to the 5th power is 3 times 3 times 3 times 3 times 3, which is 243. Okay. So again, this part here is review. We've done that before. The only new thing was changing this to this. After that, it was review. Okay? So the hard part is review. That's not bad. Okay? So I want you to do letter C now. Do 4C. 4C. I want you to do 4C on your own. I'll give you a few minutes and then we'll go over it. Okay? Okay. So how many pairs am I looking for? Or how many of a kind am I looking for? 3. Do I have 3? Nope. So what do? Break down 512 to see if there's any hidden in there. 512 is going to have a lot of 2s. A lot of 2s. 512 is 32 times 16. So you're going to have a lot of 2s. See, we got 1, 2, 3, 4, 5, 6, 7, 8, 9 2s. Did I count them all? No, I think I should have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that's right. 9 2s. So how many 2s do I have total if I have 9 2s for 512? 18 2s total. I have 18 2s total. Looking for groups of 3, so how many do I have? There you go. 2 to the 6, which is the same thing as 64. Okay. Okay, so today what we're going to do is